As educators and developers, we understand the importance of providing an engaging and seamless learning experience for our students. By optimizing our code using Intel's technology, we can significantly improve the performance and resource utilization of our quiz generation system. The usage of Intel extension for PyTorch, that is IPX, which is an Intel software library designed to enhance the performance of PyTorch deep learning models on Intel architectures. Incorporating Intel extension for PyTorch into the process of generating quizzes for an online education platform can enhance performance, improve resource utilization, and ensure compatibility with Intel architectures, and seamlessly integrate with existing PyTorch-based workflows. These optimizations ultimately contribute to a smoother and more efficient experience for users accessing the online education platform. Let's now see what is included in this code and how it works. We first need to install various libraries and extensions that are used for different purposes, such as keyword extraction, text wrapping, string similarity calculation, and sentence embeddings, performance optimization for deep learning on Intel CPU. The Flash text library provides a faster and memory efficient way to search and replace keywords in text. PKE is a Python library for key phrase extraction. Transformers library provides state-of-art pre-trained models for natural language processing tasks such as text classification and named entity recognition. Sentence piece is used for unsupervised text tokenization, which is used by some transformer-based model. TextWrap 3 provides advanced text wrapping capabilities, including indentation control and hanging indentation. strsim is a library for calculating string similarity matrices. Sense2vec provides vector representations for words and phrases. IPython AutoTime library, which is an IPython extension that automatically measures and displays the execution time of each cell. We will then activate the AutoTime extension, which enables automatic timing of cell execution in IPython. Sentence Transformers provides pre-trained model for computing sentence embedding, which are vector representation of sentences. And the Intel extension for PyTorch is a set of optimized deep learning operators for PyTorch that can improve performance on Intel CPUs. We have imported the wrap function from TextWrap3 library. The wrap function is used to wrap text into paragraph of a specified width. The code takes text and wrap it into paragraph where each line is no longer than 150 characters. It then prints each wrapped line, creating a visually formatted output. The wrap function is helpful when we want to control the width of text and ensure it fit within a specified column or layout. The summarization of text with T5. We have imported a PyTorch library, which is a popular deep learning framework. Each line of this code is responsible for setting up the environment, loading T5 model and tokenizer, configuring the device, and optimizing the model for improved performance on Intel's CPU using Intel extension for PyTorch. We have imported random module, which provide function for generating random numbers and selecting random elements. And then we have imported the NumPy library. def set seed is a function that takes integer seed as an argument and then set the random seed for NumPy module, PyTorch's random number generator, and for the GPUs available for PyTorch to ensure random number generation and operation. Call the setSeed function and set the seed to 42, ensuring random number operation across different libraries. Also, import the natural language toolkit and download NLTK data packages. Import the WordNet module from NLTK corpus. It provides access to WordNet's lexical resources. and import the sendTokenize function from NLTK's tokenization module, which is used to tokenize text into sentences. We have defined a function post-process_text that takes a content string as an argument, and in it we have initialized an empty string called final. Then starts a loop where each iteration processes a sentence obtained by tokenizing the content using sendTokenize function. Capitalize the first letter of sentence and append it to the final variable. Then return the final string variable. A function called summarizer that takes three arguments: text, which is the input text to summarize, model, which is the T5 model for summarization, and tokenizer, the tokenizer for the T5 model. This code begins by importing necessary libraries, including NLTK for natural language processing task, the string module for string operation, and PKE for key phrase, traceback for handling exception. A function called getNounsMultipit is defined, which takes a content string as input and initialize an empty list called out. We have instance of multipart rank key phrase extraction model from PKE, and the content is loaded into model with the specified language, that is English. Parts of speech tag are defined to filter the candidate key phrase, and a stop list is created by combining punctuation mark, additional punctuation mark, and English stop word for the NLTK corpus. Candidate selection is performed based on defined parts of speech tag, filtering out irrelevant words. The candidate weighing algorithm is applied to rank the selected candidates based on their scores. Top 15 key phrases are retrieved, and each key phrase is extracted and appended to the out list. Exception handling is implemented to catch any error that occur during key phrase extraction, setting out to an empty list and printing the traceback information. Finally, the out list is returned. Additionally, the code introduces keyword processor class from the flash text library for efficient keyword extraction and replacement, and defines a function called getKeywords that takes two arguments, original text and summary text. We have load a pre-trained T5 model for question generation and initializing a tokenizer specific to the T5 model. The T5 model is moved to the specified device for computation and optimized using Intel extensions for PyTorch IPX. A function called getQuestion is defined, which takes context, answer, model, and tokenizer as inputs. The context and answer are combined into formatted string and encoded using tokenizer, ensuring a maximum length of 384 tokens. The input IDs and attention mask are extracted from encoding. T5 model is used to generate the questions, specifying parameters such as number of beam, maximum length, and no repeat n-gram size. The generated question is decoded into human-readable text by removing special tokens. The question is extracted from the decoded output, and any leading or trailing white space is removed. The generated question is then returned. The code then iterates over the summarized text and extracted the important keywords. Summarized text is printed with the lines wrapped at maximum width of 150 characters. The code enters a loop over extracted important keyword and the generated question using generateQuestion function, providing the summarized text and current answer keyword. The context variable holds the text from which questions will be generated. The generate question function is defined, which takes a context as input. The summarizer function is called to summarize the context using specified summary model. And tokenizer. The summarized text is stored in the summarized text variable. The get keyword function is called to extract important keyword from context in summary text. The extracted keyword are stored in the NP variable. The empty string variable called output is initialized to store the generated question, answer, distractors, and summary. We have also defined the get distractor function, which is used to generate distractors for the current keyword based on question, sense to vec model, and a sentence transformer model. The generated distractors are stored in the distractors variable. The generated question is appended to output with the question prefix. The correct answer is appended to the output with the answer prefix. If there are any distractors, a header file for distractor section is added to the output. The generate question function is called with the context as input and output is printed. The function generate multiple choice questions with their answer, distractor, and a summary based on the given context is called. So it will print the generated question based on the input given. So now we dived deep into the code behind quiz generation and uncovered how Intel's optimization techniques transformed the way we created quizzes for our online education platform. Online education platforms have become increasingly popular, offering a wealth of courses and learning materials to millions of students. However, with such vast repositories of content, it becomes very challenging for learners to find the most relevant resources for their individual needs. This is where recommendation systems come in. Unfortunately, Intel's optimization for scikit-learn and Modern offer a game-changing solution. Data pre-processing tasks such as feature extraction, scaling, and normalization are performed using Intel's OneAPI data analytics library, that is OneDel. These optimized algorithms enable faster training, improving the efficiency of the recommendation system. Let's now dive into the code and explore how to integrate Intel's optimization for scikit-learn, that is scikit-learn IntelX, and Modern into the development of recommendation system. So the code begins with installing and configuring Intel's optimization and libraries. This will install LangDetect package. It is a Python wrapper for Google's language detection library. Then this will install Modern package with extras. Modern is a library that provides a pandas-like API while utilizing multiple cores or nodes to accelerate the data processing. Then pip install scikit-learn IntelX will install the sklearn IntelX package. It is a library that integrates Intel's OneAPI data analytics library with sklearn, which enables accelerated ML operations on Intel's CPU. Patch sklearn function is imported from sklearnx and then it is invoked. This function applies necessary patches to replace certain sklearn function with their optimized Intel versions. We have imported NumPy and harmonic mean function from statistic module. It provides function for statistical calculations. We will import the detect function from LangDetect module, which is used for language detection and to identify language of a given text. Then we have imported three classes: TF-IDF vectorizer, TF-IDF transformer, and count vectorizer. TF-IDF vectorizer is used to convert collection of raw documents into matrix of TF-IDF features. Transformer is used to transform a count matrix into a normalized TF-IDF representation, and count vectorizer is used to convert a collection of text document into a matrix of token counts. This min-max scaler is a sklearn class used for feature scaling, and it is from the pre-processing module. It scales the input features to a specified range between 0 and 1. And it does this by linearly mapping the min-max values. Then we have imported the F1 score function. It will measure model's accuracy based on precision and recall. Then the cosine similarity function calculates cosine similarity between pairs of samples, which is a measure of similarity between two vectors. Then we have imported modern.pandas. It is used to read the CSV files. By executing df.drop command, the column unnamed 0 and course organization will be dropped from the data frame, and the data frame will be modified accordingly. The data frame will be modified to contain only the rows where the course student enrolled column ends with K, and the rows with value ending in other character will be executed. By executing this line, course student enrolled column of the data frame will be modified to contain the actual number of students, assuming the original value end with 1000. The scaled rating variable will contain the scaled value of course rating and course student enrolled column from the data frame. Scaling ensures that value of these columns are within the specified range between 0 and 1 based on the min and max value of each column. The course rating is equal to scaled rating. So this course rating and course student enrolled column of the data frame will contain the scaled values, and the overall rating column will contain the harmonic mean of the scaled values. The data frame will be modified to contain only the rows where the language detected for the course title column is English. Rows with title in other language will be executed. TF-IDF matrix representation of course title column of the DF will be contained in the vectors variable, where each row of the matrix represent a document and each column represent a unique term weighted by its TF-IDF value. This matrix can be used for further analysis or say machine learning tasks. We have defined a function recommend by course title. It is used to get the book recommendation, which is based on the provided title by the user. The function returns a data frame containing the recommended books, and it is sorted by their overall rating. Recommend by course title, and in parentheses we have written Python. This is the title given by the user. This will return a data frame containing this recommended books, which is related to Python, and this is also sorted by its overall rating. The exact recommendation will depend on the data and the similarity scores. They are calculated based on the TF-IDF vector and cosine similarity. So, by leveraging the optimization provided by Intel, recommendation system can handle larger data set, process data more efficiently, and deliver personalized recommendation to learners in a fraction of time. So here's the demonstration of the chatbot code, which is the intelligent backbone of our online education platform. We will explore the inner workings of this remarkable technology, understanding how it enables personalized learning experiences for our students. At the heart of our chatbot lies a powerful combination of Intel's optimization for natural language processing and machine learning techniques, which enables it to understand and respond to student queries in a way that feels human-like, making learning more accessible and engaging. So by utilizing Intel's 1DNN, the chatbot can process and analyze user queries faster, resulting in quicker responses. And for the NLP task, it is used to accelerate operations like tokenization, word embedding, and sequence processing. Intel optimization for TensorFlow has the ability to accelerate Keras models, particularly useful when training the underlying natural language processing models of a chatbot, thus improving the efficiency of building models. It includes optimized implementation of optimization algorithms such as stochastic gradient descendant. Let's now go through the code. First of all, we have imported all the necessary libraries required to train the chatbot. We will import the Natural Language Toolkit library, which is used to train the machine learning model. And then we have downloaded the required tokenization data from NLTK. The word net limitizer is used to reduce the words to their base or say directory form, and then we have initialized the instance of it. We have imported JSON and Pickle module, JSON for working with JSON data and Pickle for serialization and deserialization of Python objects. From TensorFlow, we have imported the Keras, which is a high-level neural network API, and then the mixed precision module is used to work with mixed and float data type. NumPy here is used for numerical calculations, and the sequential model from Keras is used to build a neural network layer by layer, and for that purpose the dense, activation and dropout is used. This model will iterate over the intents defined in the intents.json file. It will tokenize each pattern in the intents, add the words to the vocabulary, and creates the document. Then we have lemmatized the words and converted them to lower cases, and duplicates have been removed to save the words and classes into the pickle files. We have created the training data by converting patterns into bag of words representation and generating corresponding output label. It will then shuffle and convert training data into NumPy arrays. This defines and compiles a sequential model with 3 layers. It trains the model on training data and saves it as a file. Thus, our model has been trained. Okay, now for the chatbot to use this model, we have imported the load model function from Keras. It will load the train model, and this will load the intents, words and classes from their respective files. We then need to tokenize and lematize the input sentences and convert them into bag of word representation using provided vocab. This predict class function is defined to predict the input of input sentence using the train model. The get response function retrieves a random response from intent based on the predicted intent. And the chatbot response takes user input and returns the chatbot response by calling the above functions. And this will prompt the user for input and continues until the user enter exit. Let's now see how this chatbot works. If we ask him, tell me about the study material provided. Or if we ask, how can I perform Vectorization in Intel 1 API. It will reply us with the steps so that we can perform vectorization in Intel 1 API. Or else we can ask, how can I optimize the memory usage with Intel 1 API? It will reply us with the desired output. So in this way, overall, if we see, it uses the Intel optimization for training the model and generating a response based on predefined intents. There is a vast array of educational resources, including articles, research papers, and course materials, and this sheer volume of information can overwhelm learners, making it difficult to identify and absorb the most important details. By employing advanced natural language processing techniques, text summarization algorithm can analyze and condense lengthy text into concise summaries that capture the essence of the content. Text summarization can significantly benefit online learners by providing them with quick and efficient access to key information. Learners can save time, focus on the most critical concept, and easily grasp the main ideas of content they are studying. Now imagine taking the power of Intel's optimization for scikit-learn, that is scikit-learn Intellect, and integrating it into the text summarization algorithm. This optimization toolkit harnesses the advanced features of Intel processor to enhance the performance and efficiency of text processing tasks. By leveraging Intel's optimization, text summarization algorithm can process large volume of text with improved speed and accuracy, allowing learners to generate summaries quickly and reliably. We have used a basic approach to extractive text summarization using TF-IDF scoring. So let's go through the code and understand how it works. Pip install scikit-learn Intellect will install the scikit-learn Intellect package, which is an optimized version of scikit-learn library for faster computation on Intel CPU. Import NLTK will import the Natural Language Toolkit library, which provides various tools and methods for natural language processing. Then we have imported NumPy library, which is a popular library for numerical computing in Python. This imports patch sklearn function from sklearn module. It is used to patch scikit-learn to use the optimized version provided by the scikit-learn Intellect. From sklearn.featureextraction.txt, we have imported countVectorizer class, which is used to convert the text document into a matrix of token counts. Then we have imported the TF-IDF transformer class from scikit-learn, which is used to transform a count matrix to a normalized TF-IDF representation. This input text variable contains the whole text which needs to be summarized. So this defines a multi-line string that contains the input text we want to summarize. Sentences variable will tokenize the input text into sentences using sendTokenize function from NLTK. Then we have created instance of the countVector class. This will fit the countVectorizer to the sentences and transform the sentences into a matrix of token counts. Then again we have created another instance, but now it is of TF-IDF transformer class. This then fits the TF-IDF transformer to the count matrix and transform it into the TF-IDF matrix. Sentences scores will compute the scores for each sentence by summing the TF-IDF value for each sentence and squeezing the result into a one-dimensional array using NumPy. sorted indices variable will sort the sentence course in descending order and returns the indices that would sort the array. Then this defines the number of top sentences to include in the summary. The summary sentences has a for loop will select the top num sentences from the sentences from list based on the sorted indices. This will then join the selected summary sentences into a single string, separating each sentence by a space. Print generated summary will print a label indicating that the following line is a generated summary. And finally, we will print the generated summary itself.
Hi, in this video I will be showcasing you a prototype of our web app built from Next.js as a full stack framework and Tailwind CSS framework. So let's start with landing page. One of the key feature of our landing page is robust authentication system. So if we try to access the dashboard without login or sign up, you will redirect again to the authenticated page. See this. You again come to the authenticate page. In this we have credential, sign up and login, and also we have sign up with Google and sign up with Twitter. So let's sign up with Google. Now here on dashboard you will see recommended course for you, which dynamically change, and also have schedule today. We also deployed it on the Vercel, but we can't deploy chatbot as it requires large amount of space for downloading their libraries. If I show you the Vercel app deployed, here you can see the Vercel app and Knights Vercel, and here you can see the recommended course for that introduction to big data and data engineering. Big data, this is a course which is suggested by the recommendation system, and here you can also ask question, but the is response haven't generated because it don't connected with the chatbot system.